Hello, how you doing? In this video, we're going to talk about Mojo. In the context of the AI world, have you heard the term Mojo? And you're not quite sure you know exactly what this is. Well, if so, then watch along with me for the next few minutes and I'll quickly get you up to speed. Okay, let's get started. Mojo is a new programming language designed to combine the ease of Python with the performance capabilities of languages like C++. Mojo is primarily targeting engineers building AI ML workloads. Mojo is being developed by MLIR, an AI infrastructure company founded by Chris Slatner and Tim Davis. Chris Slatner is well known for creating the LLVM compiler infrastructure and working with Swift, Apple's programming language. MLIR aims to unify and simplify AI development with Mojo, creating a high-performance language that retains Python's usability while delivering the speed and low-level control needed for demanding AI ML use cases. Mojo is fully interoperable with Python, allowing developers to leverage existing Python libraries and ecosystems while introducing advanced performance optimizations where needed. Mojo introduces memory management features like ownership, borrowing, and references, inspired by systems programming languages like Rust to enable safer and more efficient memory management. Mojo starts with front-end parser that reads and interprets high-level Mojo syntax. This stage translates the human-readable Mojo code into an abstract syntax tree representing the structure of the code. The structure of the code includes functions, variables, loops, etc. After parsing the abstract syntax tree, it's converted into Mojo-specific dialect in MLIR. MLIR stands for Multi-Level Intermediate Representation. MLIR supports custom dialects to handle domain-specific optimizations. Mojo takes advantage of this by defining its own high-level constructs. Examples of the Mojo-specific language constructs are tensor operations, ownership, and borrowing. This allows Mojo's unique language features to be represented in MLIR, enabling specialized optimizations for AI, ML, and performance-critical tasks. After high-level optimizations, Mojo's high-level abstractions like tensor operations or parallel processing are lowered into lower-level MLIR representations, which are more hardware agnostic. These lower-level dialects represent the code in a way that can be easily converted to LLVM IR. LLVM stands for Low-Level Virtual Machine. IR, which stands for Intermediate Representation, is a single abstract machine-independent code representation used by compilers as an intermediate step between source code like Mojo, C, Python, etc., and machine code. Lastly, by the time Mojo's code reaches IR, it is ready for final hardware-specific optimizations and then compilation into machine code for CPUs, GPUs, or custom hardware accelerators. Mojo uses LLVM to compile and optimize its code, allowing it to generate efficient machine code across various hardware architectures, including CPUs, GPUs, and custom hardware. LLVM, working with MLIR, enables Mojo to translate its high-level Python-like code into optimized low-level instructions. In summary, Mojo's front end first parses the code into an abstract syntax tree and then converts it into Mojo-specific dialect in MLIR for high-level optimization and progressively lowers it to LLVM IR. This pipeline allows Mojo to balance the ease of high-level programming with the performance benefits of low-level optimizations. MLIR and LLVM work together to provide a powerful and flexible compilation pipeline, taking human-readable Mojo code and convert it into hardware-specific machine code. So, do you need to be using Mojo? Well, one of the primary drivers behind its popularity is its focus on solving the two-language problem faced by many AI developers who often switch between Python for ease of use and other low-level languages like C++ or Rust for performance. If you have this problem, Mojo may be for you. Another scenario where Mojo could be for you is if your project involves training deep learning models, running inference, or running complex data pipelines that require optimization on hardware like GPUs, TPUs, or AI-specific chips. In these types of scenarios, Mojo has seen performance improvements of up to 68,000x compared to Python. Now, alternatively, if you're building user systems in the cloud, integrating with LLMs and vector databases, you likely don't need Mojo. With these use cases, your systems are not leveraging GPUs or custom hardware accelerators, so using languages like Python, Node.js, .NET, or Java will be fine. So now you should have a good high-level conceptual understanding of Modular's Mojo language and its use cases, and which match up well for this exciting new language. Okay, thanks for watching. This video, along with all my other videos in the AI LLM Concepts playlist, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing, we all love technology, and we're all excited about the innovation with the cloud and machine learning AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go climbing, go surfing. Get out and move your body. And if you do, tell me in the comments. I want to hear about it. And with that, have a great day. Thank you.